Hello and welcome to my channel. Is Noble Hero here. We want to solve this equation here that says that we should find the derivative of sec x from first principle. Alright, so now to solve this equation, I would like us to draw a particular formula that we're going to use in solving that, and also take note of a particular other formula that we're going to use. Alright, so here I would like us to um, start by analyzing cos A plus B and cos A minus B. Then cos A plus B, we know that to be cos A cos B minus sine A sine B. And these would be cos A cos B plus sine A sine B. And then we're going to subtract these equations here. So we're going to subtract cos A plus B from subtract these and these. So what are we going to have if we subtract this from these? So that means we subtract. Now we're going to have these minus these. That's the same thing. So it's going to give us 0. Then we're going to have negative this minus this. That should give us a negative 2 of these things here, which is negative sine A sine B. All right. Now that we have this, we are going to say let A plus B be equals to X, and then A minus B be equals to Y. All right. So we're going to call this equation 1 and call this equation 2, and then I'm going to subtract this equation here. So if I subtract this from this, if I subtract these two, I'm going to have A minus A, which is gone. B minus minus B, that becomes B plus B. That gives us 2B. Then we have X minus Y. X minus Y. So from here, we have B to be equals to X minus Y divided by 2. Alright, so if I reverse the process and instead of subtracting, I'm now adding. If I add that, I'm going to have this plus this, which gives us 2A. This plus minus, so plus minus becomes minus, so B minus B is off. Then we have X plus Y, so that will be equal to X plus Y, and we divide both sides by 2. We have that A is X plus Y divided by 2. Now with this, if I take it back to this equation here that we have now, so let me box this up and let's go back to what we have there. Now this is going to become cos A plus B is X, so cos X minus A minus B is going to be our Y, so we have cos Y equals to, we have negative 2, then we have sine, where our A is this, so we're going to have sine X plus Y divided by 2, and then sine, our B is X minus Y over 2, so we have here X minus Y over 2. Now this is going to be the formula we're going to use, so take note of that formula. And then another formula I want you to take note of is that the limit of sine X over X as X tends to 0 is equal to 1. So let's take note of this. Alright. So I'm going to clean these up, and then we're going to use this formula to solve. Alright, so now let's go into doing this. So we're going to start by saying y equals to sec x, and then we're going to take the partial additive of this. So it's going to be y plus dy equal to x sec. This is going to be x plus partial differential of x. Okay. And then from here I'm going to move y to the other side, so that we have that dy equals to sec of x plus dx minus y. And let's recall this y. Okay, so this should be sec x plus dx minus sec of x. Now let's recall that sec of any angle is equal to 1 over cos. So here we're going to say that partial dy would be 1 all over cos of x plus dx minus 1 all over cos of the angle here, x. Alright, so the LCM, we know what the LCM is. And with that, we should note that this is going to be the same as cos x minus cos into bracket x plus dx all over cos x plus dx. Alright, so from here now, we're going to use this equation here with this. And if you want to relate this equation with this now, for this, I'm going to change these letters. So let's call this u. Let's call x u, so that it makes sense. Alright, so cos u minus cos y, we're going to take it this way, cos x minus cos this, which means that our u is x and our y is this. Now we're going to express this in this other form. And so we're going to do what? We're going to put in these values here in this form. Alright, so that would be dy equals to, so since we have cos x minus cos this, and these are u and these are y, the first instance we should write minus 2 first. So we're going to write minus 2, and then we should write sign. So I'm going to write sign. And then the principle says we should add the angles. So we're going to add these angles now. So we're going to add x to x plus dx. And that would give us 2x plus dx. Then we should divide it by 2. We're going to divide it by 2. Minus, sorry, there's no minus sign, sorry. After that, we go with sign again, sign u minus y. So that means these are u, these are y. We're going to subtract that. So we're going to say u, which is x minus x plus the x. So that's going to be x minus the x. Alright? And x minus x is gone. So we're left with minus the x. So I'm going to put it down here, minus dx. And then we divide by 2. Okay. So we've just been able to transform our cos of an angle minus cos of another angle into this other form. Cos of one angle minus cos of another angle should be equal to this. We've done that. We've changed it into the one that contains sine, and this is what we've done. So the whole of the numerator is now containing sine, and then divided by the denominator. And what we have on the denominator is cos x plus dx. So this is what we have on the denominator. And now we need to take note of something, that sine of a negative value, sine of a negative angle is negative. So if this is negative, so we have a negative sign of this. Negative and negative, remember this is multiplying itself. So this negative value multiplied to another negative value will give us a positive value. Alright, so let's express that first. So this becomes positive value, so it's no longer negative. So we will just have 2 sine 2x plus dx all over 2. Then we have sine dx over 2 all over cos x cos into bracket x plus dx. Alright, so that's what we have. Now permit me to clean this off so we can continue. Alright, so we're going to continue from here. Now we have dy equal to 2 sine into bracket 2x plus dx over 2 sine dx over 2 divided by cos x cos times cos x plus dx. Alright, so here now we're going to divide both sides by dx. So this change in y over change in x will now be equal to 2 sine 2x plus dx over 2 sine dx over 2 all over cos x cos x plus dx. And then remember, we're going to divide both sides by dx. So we've divided this side by dx. We have to divide this side also by dx. That means dx is going to be on the denominator. Remember, this is the numerator, this is the denominator. Alright, so now we have sine dx. Remember, we said something about limit as sine x over x is going to give us 1 if x is tending towards 0. So now, if you look at it now, we have sine of this over this, but this is not complete because we need divided by 2. This and this must be the same. Alright, so I'm going to divide the denominator by 2. So I've divided the denominator here by 2. I need to balance the equation by dividing the numerator also by 2. So I'm going to divide something here in the numerator by 2. So 2 cancel 2 out, and we have this. So we're going to take now the limit of this equation. So we take the limit as the x tends to 0 of change in y or change in x, and that will be equal to sine 2x plus dx over 2. Let me put that down, the limit as the x tends to 0 of this, right, times the limit as the x tends to 0 of dx over 2, sine dx over 2 divided by this dx over 2. Now on the denominator, limit, you can't take the limit of this, so we take the limit of this, so cos x is out because it doesn't contain dx, and then limit as the x tends to 0 of cos x plus dx. Alright, now in case you're looking for this, we've divided this by this. Remember, this divided by this. That's what I'm written down there. Alright, so that's what we have, and then we have to take the limits now. Alright. So the whole of this is going to give us the limit of this is going to give us dy dx, so dy dx equal to the limit of this, when you insert the x as 0, this will be 2x plus 0 divided by 2x. So this becomes 2x over 2, which is sent as sine x. So we have sine x multiplied to, this is 1, right? Limit of this is 1 because limit as the x tends to 0. So the limit of the x over 2 would also be tending to 0. Okay? The limit of the x, if the limit of the x is going towards 0, then the x over 2, which is 0 divided by 2, will still be tending towards 0. Alright, so now this is going to give us 1. So that will be like times 1 over, we have a cos x, so put it down, cos x multiplied to the limit of this, is going to be cos x plus 0. That becomes cos x. So we have another cos x here. So dy, the x is the same thing as sine x over cos x dot cos x, right? This and this will give you tan, and 1 over cos is sec x. Alright, so that will be the answer. So if y is equal to sec x, dy dx is going to be tan x sec x. Alright, so I hope that the video has been interesting and hope you've learned something. Please subscribe, like the video, share it to people that you know is going to be of use to them. So please, still your boy Noble Hero, and please support in any way you can, and your comments would really be appreciated. If there's anything you want me to do to improve on, you can tell me on the comment section. Thank you.